One of the most dangerous phases in any facility is this: how we have always done it. In the traditional maintenance, plans are often created during the commissioning of a plant and then set and forgotten. These plans are frequently based on original equipment manufacturer manuals, which are designed for average conditions, not the specific physical reality of a unique facility. You will learn that a static maintenance plan is a primary source of information latency. As the machines age, as production volumes increase, or as environmental conditions change, the old plan becomes less effective. If the maintenance schedule does not evolve, the operation eventually falls back into a cycle of guesswork. The asset intelligence framework requires a strategic maintenance audit, a systemic review to ensure that every hour of labor, every dollar of capital spent on maintenance is directly contributing to the default engine. The audit is not a one-time event. It is a continuous feedback loop. You will discover how to move from a static annual review to a dynamic audit. This involves using the data gathered from the AI Copilot and edge intelligence to challenge every task in the current maintenance schedule. The audit asks a simple but profound question: why are we doing this task at this frequency? If the root cause physics shows that a specific component is currently under zero stress and has a perfect health score, the audit provides the justification to extend the service interval. This is about removing the guesswork from the schedule itself. By constantly auditing the plan against the actual physical health of the machines, the facility ensures that it is never over-maintaining healthy equipment or under-maintaining high-risk assets. Asset criticality is not a permanent status. It is a variable that changes with the market. You will see that a machine that was low priority last year might become the critical path this year due to a change in customer demand or a new $1.2 million contract. The strategic maintenance audit forces a criticality realignment. This involves mapping the maintenance schedule against the current commercial goals of the business. If a particular production line is responsible for 90% of the quarter's revenue, the audit ensures that the line receives the most sophisticated sensors, the tightest diagnostic tolerances, and the most aggressive just-in-time spare part support. This ensures that the maintenance effort is always concentrated where the financial stakes are high. It stops the waste of equal effort for all assets and moves toward maximum effort for maximum impact. A shocking amount of maintenance activity actually introduces failure into the system. This is known as maintenance-induced failure, and it often happens when a healthy machine is opened up for a standard check. You will find that the strategic maintenance audit is a powerful tool for deleting low-value tasks. By analyzing historical failure data and information integrity, the audit identifies tasks that have a high cost but zero impact on reliability. For example, if a manual inspection has never once identified a fault in 5 years, the audit suggests replacing that manual task with an automated sensor. This eliminates the waste of movement and reduces the risk of human error causing a breakdown during the inspection itself. This is the process of trimming the fat from the maintenance budget to focus exclusively on the high-value physics of the machine. The final component of the audit is the knowledge loop. This is where the results of every surgical repair and autonomous diagnostic are fed back into the master maintenance strategy. If the AI Copilot identifies a new failure mode that wasn't in the original OEM manual, the audit ensures that this new intelligence is codified into the permanent plan. This creates a facility that actually gets smarter as it ages. Instead of a slow slide into deterioration, the operation becomes more predictable and more stable over time. The total economic loss discussed in earlier modules is permanently reduced because the plan is constantly being optimized to prevent the next physical surprise before it can happen. The challenge for this session is to pick the top 5 most time-consuming maintenance tasks in the current schedule. Audit them against the last 12 months of failure data. Did those tasks prevent a breakdown, or were they simply done because the manual said so? You will discover that at least one of those tasks is likely a candidate for deletion or automation. By cleaning up the maintenance plan, you ensure that every hour of labor is spent on what actually matters. But a leaner, smarter plan is only useful if the leadership can see the results in real time. In the next session, Module 17, the Asset Health Index and Executive Governance, you will learn how to turn these technical signals and audit results into a single high-level scope that the boardroom can use to manage commercial risk.